So I might have to tone it down. So it might end up being boring to some of the people in tech and Bo, especially, who knows a lot about it. But I guess that's the only way to do it. I'm going to be very, very high level.
Right. Only a limited number of students they stood out because they were new to the user group.
Okay. I'll go as deep as you want, so no worries. All right. So like I said, product was product came out of Sweden from a company founded in 2005. NSO was not there in 2005. The first product they had was called conf-d. Basically, what that was is a netconf stack. Has anyone heard about netconf? Great. If you haven't, that's the next thing you should know, because every vendor that's selling hardware, and even in the SDN side of things, is supporting this protocol called netconf. So netconf basically allows you to configure things on either physical or virtual hardware, right? What do you use now? You use CLI, or sometimes you have an element manager, which has got a GUI and you use the GUI, right? But these are things that humans do. I mean, you can do only one thing at a time, right? If you're doing the same thing over and over again, you want to automate the whole thing, right? You can write CLI scripts to automate stuff, but that's not very efficient to do it using CLI. That's where netconf comes in, okay? So netconf is an IETF standard protocol. There's an RFC behind it, 6028. Every vendor these days is supporting this protocol. In fact, most of the tier 1s and tier 2s these days would not buy a new hardware if it doesn't support netconf, because that's the only way to automate configuration management, okay? So back in 2005, this company came up with a stack for netconf. So basically, you drop it into your device, and then you can do some programming to expose the device model through netconf. So now, your device supports both traditional CLI and it has netconf. That was the first product they had. And then they invented this product called NCS back then, which is now NSO. Basically, it's a network operating system. That's what it does. Makes any sense? The operating system for Cisco is like iOS, iOS XR, Nexus, StarOS. These are all operating systems that work on physical hardware. So you type in commands like show running config, path map, config policy map, whatever stuff, right? That's the operating system at the device level. This is the operating system at the network level, right? The difference is, if you want to pass traffic or create a service, you need to configure multiple devices, right? Otherwise, traffic is not going to flow, right? For example, let's see. Simple topology. We have an MPLS cloud here. This is a lab topology which has four devices connected to the MPLS cloud, and then 4 devices hanging off these, right? This is a topology. This is EVPLAN MEF service. Has anyone heard MEF? Metro Ethernet Forum? Yeah. Okay. It's like IETF. They standardize on services like layer 2, layer 3, layer 4 services. So they have a service called EVPLAN. They said this is how an EVPLAN should be configured. So the configuration goes on 4 devices. Clarity is pretty bad. Okay. Can people in the back see this, or is it kind of blurry?
It's a little small. I'm on the front row, and I'm sure you'll give us your slides at the end. He's going to give you a clicker, but show us.
Okay. Anyhow, so This is a ASR 9K, these two. They're on iOS XR, okay? So to configure this service, it's a point to multi-point service, by the way, right? So it goes on 4 devices. On here, you need...
Oh, that was me.
He's trying to give you a clicker, so you don't have to walk back and get the advance.
That wasn't me. What?
Hey, click continue.
It's not on the screen.
No, ma'am. So just disconnect from the projector.
So, what are you, just off?
Yeah, I tried.
Okay, so it's gone, right? So it should...
Yeah, no, it should go away.
The mouse is not working. Okay, this is better. I can walk this out. It's not it's too bad. All right, so
We've had this problem before with Apple.
This is not you, yeah, this is the
don't worry.
It's the Apple.
All right. Okay, good. So the service goes on 4 devices, agreed? I haven't shown the configuration on the edge devices, but there's 4 devices in place here. And this is the lines in CLI that you would need to write to each of these devices. So if somebody were to manually configure this service, they will have to CLI into this device, type, however, 10 lines over here, go do the same thing on this device. These are iOS XR, by the way, and these are iOS devices. And then you type about 15 lines on this one and 15 lines on that one. That's when the service is fully provisioned, right? So device operating system, 4 times over. Now, you have a network operating system. All you do is type this in the network operating system. It turns it on and writes this on all these 4 devices, same time. Make sense? That's what a network operating system does. The beauty of this thing is the device operating system, these CLI commands are hard-coded by the designer who designed iOS XR. You can't change that, right? It's always going to be L2 config, L2 begin, British group, something. That's hard-coded. And you probably learn it on your CCNA course or whatever it is. This is how you configure this. This is how you configure the interface. Network operating system, NSO out of the box, doesn't do anything. It's just an operating system. You have to design the service. In this case, you are designing an EVP line service. There's nothing out of the box that says configure EVP line service. You have to design the service. It gives you the power to design it, which means when you design the service, it automatically renders the CLI based on how you define the service. So now you have the power to create a CLI to your liking, the way you want it. Make sense? You are in control now. Imagine if you had the power to create commands inside your iOS XR. That's the power you're getting now. Okay? That's the network operating system does. And when you create this, the service, well, let's assume that you have to delete this whole service. Okay? Every service has a life cycle. There's an acronym called CRUD. Has anyone heard of it? Stands for create, update, read, and delete. Okay? Anything that you configure at some point in time, you might want to modify something. So create, C is create, that means this is the create. Create of service is going to 4 devices, typing in all this configuration, 4 devices. An update is, after you created that, somebody said, oh, wait a minute, I need to change that VLAN ID that I used over here, well, you can't see it, it says 200 over here. The VLAN ID, oh, it shouldn't be 200 because I had a block of VLAN ID assigned to per customer, and this VLAN ID I gave is for the wrong customer. It should be 300. So now imagine the pain that he has to go through to change it from 200 to 300. He has to log into, network architect has to log into this device, basically change, it's service interrupting too, by the way, because as soon as he logs in, this whole stuff is under all the neighbors. Unfortunately, you can't see, there's 3 statements under here. So if you want to change this 200 to 300, you basically have to remove this whole block, create a new one, replace it with these 3 lines inside the block. Do the same thing everywhere. Okay? That's an update. Read is for somebody to go on CLI and say, show L2VPN something. That's a read. And the delete is at some point the customer goes away. I don't know, maybe he decided to take some of the service. And then what do? You leave this in the, well, there's 2 choices you have. Now, if you have something called an operational state or an admin state, you can go and turn off the admin state and say, oh, nothing is going to happen from now on because I stopped the traffic from flowing. Leave the configuration there in the device, which is redundant configuration that does nothing, which is left in the router, or take the pains of going to each device and go, sometimes you might have to remove the neighbor manually before I let you remove this, and then you remove this, and then you remove this. Sometimes the device will let you say no L2VPN, and it'll remove the whole thing. But you still have to do that, right? So that's the whole life cycle of a service. What it does is when you create the service on the network operating system using NSO, this is the unique selling proposition of this product, by the way. You create the service from a create perspective. You define the service. You don't actually create the service. You define how the service looks like from the network operating system, and it gives you CRUD for free. Which means once you create the service using the network service operating NSO, and it gets pushed down, you can go and change any value, and it will change it everywhere. You can
Are you able to blow up the configurations there on your NSO?
Sorry?
Are you able to
make your screen larger?
Bigger right there on the section where you have the NSO? I can walk up there, it's not a problem, dude. Yeah, you don't want to do that.
Sorry, sir.
Oh, it's not a problem.
Wouldn't think I can. How do I make this big?
There should be down in the right-hand corner a percentage. You can take and increase that. There you go. Okay.
Better? Oops. Is that better?
Yes, perfect. Okay,
Got it?
got it.
What I
Now,
do
this is the NSO structure?
This is the NSO CLI command structure, not the service definition.
And if I need to have a VLAN and service IDs that are different on every box because I'm a service provider or a carrier, and every area has its own unique set of numbering schemes and bring them all into the same thing, how would I do that?
Okay, so you're talking about changing, if you're creating a different EVP LAN with a different instance? That's easy.
Same EVP LAN, I just need to have VLAN ID coming in on 200, and then take it across with my pseudo-wire ID and pop it off on 350.
Not a problem. So this particular customer wanted to share the VLAN ID separately, commonly across all devices. But if you want to do what you asked, I would change the layout of the thing to accept the VLAN ID over here. This is at the top level, which means this applies to all the 4 devices. I would just move this line inside here. As simple as that.
So what I'm doing is putting the unique sections for each box
Correct.
inside of a single service.
Correct.
I still have to create it for each box.
Correct.
and do the
I think
manual.
we're getting a little ahead in the technical details. Let him go ahead and finish, and then let's see.
Okay?
I think it'll be more obvious how you make these changes.
All right, so anyone got any questions on what a network operating system is? That's basically what I'm going to show you going forward. Dan, I don't think whether this is going to be quite applicable for this audience, but this is the marketing pitch from our product. It's the most mature orchestrator on the market. So there are other players in the field. They come from two directions. One, there were people who used to write network managers who are in the BSS space. I don't know whether BSS, you understand, the business logic section. So they were people who had GUIs, pretty GUIs, and they had all this thing modeled. So if you want a layer 2 VPN, they had created a form how to create a layer 2 VPN. And then they would come to you and say, well, this is how you create a layer 2 VPN service. And the problem is, just like the gentleman over here asked, every vendor's configuration is going to be slightly different, even for the same service, or layer 2 VPN, or layer 3 VPN, or whatever configuration you go. If you go to one customer to a different customer, there'll be variations. Okay? And when somebody comes to from this space comes down and tells you, this is how you do layer 2 VPN, you'll have to adapt to their model. You lose your model because they'll say you're wrong. This is how it has to be, right? We don't have a problem because we let the customer decide how the model should look like. Okay? The other people who come in this field are from the likes of HPNA, Ansible, and the likes. Basically, they have a playbook where they write this configuration that goes to each device, and then they say, okay, push it to this device, and they variabilize this whole thing. They won't give you full life cycle. Remember CRUD I told you? That's the create part. If you want to delete, then you have to have a different playbook. And you have to figure out how to do the delete. With NSO, you don't have to do all that. It knows which no commands to send to remove the configuration. Okay? Same with the updates. Updates is almost next to impossible to do on a playbook because there's so many attributes that are changing, that are variables, that you will write a playbook for every one of them. Okay? That's the other players in the industry. So I think from the orchestration perspective, we are unique in the sense that we have a network operating system. And not only that, ours is multi-vendor. There are other players in the market who have element managers or network managers who claim that they have a concept of a service and you can create a service across different elements, which is true, but it has to be from their shop, which means vendor X makes a CE, a P, and an edge device, and a core device. If all the entire network is made up of their gear, you can use their element network manager to do the same thing. They probably give you CRUD. But very rarely would you run into a network where every hardware in the network is from one vendor. Very, very rare.
So you're vendor agnostic.
Exactly.
Is that what you're telling me?
That's right.
So are you using an agent or your agent? Are you putting an agent on the actual device?
No, there is nothing on the device.
So you're doing an overlay. So who's actually writing the underlying code that's doing the actual configuration portion of it?
We do. Okay, let's come to it in a second. I'll just go into the details of how we do it. But good question. We don't, to make NSO work on a multi-vendor device, network, you don't have to put anything on the device at all.
Okay.
Nothing on the device. You can create a service from an edge, which is an Arista device, to an CE, which is a Cisco device, to a P, which is a Juniper device, to terminating in another vendor's hardware, Alcatel hardware. And on the other side, the same thing. Just one service will write to all these vendors' hardware configuration. Same time.
It automatically identifies the hardware?
Sorry?
It automatically identifies the hardware it's connected to?
No, it doesn't identify the hardware. It will if the device speaks netcon. Okay? Good question. If it doesn't speak netcon, when you onboard the device into NSO, it means NSO has to discover the devices. At the discovery time, you tell what vendor's hardware, not actually what vendor's hardware, you basically tell what operating system the device is running, right? So if it's an ASR 9000, you would say it's running iOS XR. You wouldn't say it is ASR 9000. You would say the operating system on this IP address is an iOS XR, okay? But if it's netcon device, like there's so many, like I said, many vendors are coming out with netcon device, you just put the IP address and say the protocol is netcon. Netcon has a hello message. Basically, what the hello message, as soon as the NSO talks to the device, it'll send a hello message, and the response back will tell us exactly what commands are supported, what its capabilities are, and what device type it is. Okay. So
You're saying that it broadcasts, let's say that you load it up from, say, a host or workstation, and then it broadcasts itself, or do you have to go and load it up onto a switch or a router?
The onboarding process has to be done manually. Two options. Well, you can onboard it. You have to onboard an NSO. Basically, when you active onboarding is basically you say, what's the name of the device you want to call inside NSO, right? It's usually customers use the host name, which is the most logical thing to use. Second thing you need to know is what's the management IP address. Okay? And the third thing you need to tell NSO is what operating system is running on the device. And one more thing, the username and the password. There's a fourth.
The router?
Sorry?
What are you loading it onto?
To NSO.
Onto NSO,
Right.
which is from the cloud.
It's a server.
Okay, server. Sorry, I didn't get to it. It's NSO. The operating system runs on a Linux box. It also runs on my Mac, but unfortunately it doesn't run on Windows. So any Linux box, we are not tied to any particular flavor. It can be Ubuntu, CentOS, Green Linux, whatever it is. Just Linux is all you need. Very little dependency on the operating system itself. All you need is JDK and Python. That's all you need. And the product installs in about 2 minutes. And then you have NSO sitting there. Obviously, that box, or it can be installed in a VM, that VM should be able to connect to all the devices in your network, right? Once you're able to connect to it, then you can onboard all the devices into NSO. There is an option to onboard devices automatically using a plugin, but what it does is basically it logs into a seed router and looks at the OSPF or the BGP topology and onboards it automatically.
So how does NSO deal with the security aspect of what you're discussing? Because I'm thinking now that if I actually have the NSO box and send out, or even spoof the IP address and send out anything via netcom, you're actually going to write that to my device. So how are you actually authenticating that server?
Good question. Netconf is over SSH, right. So it's secure in that aspect. All the other devices that are not
the traffic is secure, but the source, if I spoof the source, I can still send out that. We're just still looking at basically securing the communication between the two, and the data in between is secure.
May I answer that?
So unless you have a cert that's on that box that I'm using on the other end to authenticate who it is, how are you, I mean, the endpoint is still vulnerable.
It's very similar to a user, right? So the user has a username and password, how do you authenticate your contact?
I'm just
Same
asking
thing.
logical questions because I can steal the box and still on the name of the point device.
Okay, we can talk about security. We have a module, we have full support for AAA. So basically how it is deployed in the field, the users are not configured in NSO, even though by default you can configure the user and password in NSO. What happens is it's routed to a radius or attack server. Does that help answer your question? So the request, user logs into NSO with the username and the password, it gets sent over to your Radius server, and we do authentication and authorization using your external Radius or TACAC server. Make sense?
No, that's telling me how you do the identity and access.
There's no difference here than anybody just simply logging on, okay?
Right.
So you've got the same problem of people logging on to routers and making changes with routers, okay? There's no difference there. The NetConf protocol makes use of SSH and the encryption therein, and that's pretty much the standard way that this sort of stuff has been doing with NetConf. If you want to get into the more esoteric aspects of NetConf and SSH utilization, we take that offline.
No, I don't trust my users now, but I'm just saying, thinking.
You're a security guy, I can tell.
I'm a little bit, but I'm just, I don't trust them now, so I'm just looking at it from a whole different.
No worries. We are delegated security off using AAA into Radius or TACAC. Is that good enough? Because that should be the source of truth.
Yeah, I mean, with no local database, you're basically using that LDAP to authenticate
Right.
the user. That's why I was asking, if I
Yeah.
fill the box and it's a local database, then that's my endpoint, that's my point of failure. So that's why I was asking about how you're actually securing it. Okay.
Right. All right, so it's been in the market for more 5+ years. Pretty much every tier 1 service provider in the U.S. Is using NSO for automation at this point in time. There are many tier 2s and tier 3s also using NSO. We have diverse use cases where people are using NSO for anything from configuring layer 2 and layer 3 services to bringing up data centers. We have customers in the financial space, banks. We have customers who are using web interconnect, from connecting Google to the Amazons using NSO. We have learned a lot in the last 5 years because we are in tier 1s where NSO is managing hundreds of thousands of devices. Okay, so scalability and performance, we have been put to the test in every tier 1, and we have stood up the challenge. So it's not like this is a nice, pretty product, put it on the field, load up 100,000 devices, and it falls on its face. No. We are scalable, and we are in every tier 1, okay? All right. Okay, so what are the business drivers? Why are customers buying NSO? It's basically operating expense, right? They can't afford to have people sitting there and typing the same commands over and over again. Assuming you take CCNA or network certification, you learn how to configure a layer 2 service or layer 3 service. Let's backtrack. What are the things that people configure a router? You get a router, customer orders a router, it comes in a box. Somebody sends the box to a site and say, go plug it in. There's no configuration in the box at this point, right? The first thing you do is what's called a day 0 config. You typically log in using the console port, if you know what it is, and you put a cable inside, either directly type in, connect a laptop to it and type in a bunch of commands to configure day 0, or you hook it up to a terminal server, and through the terminal server, somebody sitting somewhere else gets into the box and puts the day 0 configuration. The day 0 configuration is things like, what's the management IP address? That's a bare minimum. What's the host name? And then you go into day 1 configuration, where you configure things like, this is the NTP server you're going to use. This is the DNS server you're going to use. This is the SMB community string that you're going to use. These are things that you configure once, never again. Maybe you might, change the DNS server once in a while, but most of the time it's a one-time configuration. Day 0 is a one-time configuration. Day 1 is usually also a one-time configuration. It doesn't repeat over and over again. Even though DNS server and NTP server is a list, you can keep adding to it. Very rarely do people keep adding to it. Okay. After that comes the day N configurations. That's where things get repetitive, right? You create a layer 2 service for, let's say you're a service provider and you're selling bandwidth or your customer is a bank, and the bank keeps opening branches all over the U.S. And when a new branch is opened, they call up the service provider and say, hey, connect me this branch to my everything else. So they have to go configure a bunch of stuff on the edge device the bank is connecting to all the way, they have to configure all the way to the main office, correct? When they open the next branch, they have to do the same thing over again, so the same configuration repeats. That is the ideal candidate for automation, because if you're a network architect, it's great to do day 0, day 1, but day n, but after a while it gets boring, right? Because if you did one, you're basically creating the same 25 lines every day, sitting there changing a few values here and there. VLAN ID changes, interface name changes, but it gets boring and monotonous, right? Because it's typing the same stuff. You can have somebody else do it. You don't have to use your brain to figure out the entire thing, right? That's where you save on, because now the network architect can actually go figure out how to optimize the network, figure out what QoS policies to create and all that stuff, instead of sitting there executing work orders, which requires typing the same thing over and over again. So reduce OpEx by automation is what the biggest benefit is. The second benefit is the time it takes to release a new service. Because NSO, the way the software is architected, you can actually replace one vendor's hardware with a different vendor's hardware on the fly with very little effect. Because the logic on what gets pushed to the device is separated out. It's not lumped into one single service. So I'll get to the details when it gets too technical if I go deep into it, but trust me, it's much faster to do it through NSO versus using a playbook or using an in-house script that sends the configuration down, okay? This is how things are done today. You have several network engineers. Remember I said there's not one tier one that I've come across except for one. I ran into one network where the entire network was filled up with one vendor's hardware. That was very rare. The network belonged to a tribe in Upper Canada, the Cree. That was the only network that I ever saw was one vendor's hardware across the board. Other than that, it was always multiple. The way the tier ones and the tier twos play out is they will never give a contract to one vendor, simply because once they give it to one vendor, they're kind of at their vendor's mercy, right? They always have at least two vendors, so they have a choice. Yeah, price competition. There's a lot of factors that they want multiple vendors. So what ends up happening is you have, let's say you bought Cisco and another vendor. Let's say vendor X. They will have to hire somebody who knows Cisco certificate, who has got Cisco certification. He figures out the configuration that needs to be written to Cisco devices. Then they have to go find somebody who knows the operating system on vendor X hardware. Then that guy figures out how to write configuration to the other hardware. And so there's a bunch of network engineers, and then they hire somebody to write the scripts or playbooks to do this configuration management, and that's how the things play right now. So there are various CLIs, where each vendor has its own CLI, various APIs, manual activities, and all that problem. And here's where things are going. It's already started. NetConf and NIEM. NetConf, I already told you, is an IETF standard protocol. It's been around for a long time. Almost every vendor's latest operating system coming out now supports NetConf. YAN is also an IETF standard protocol, not a protocol, IETF standard modeling language. My bad. This is the protocol. This is the modeling language. Remember, sir, you asked me how do you change the VLAN ID from one to a different vendor. You define what is called as a service model. And service model is written in using Yang. It's a human-readable modeling language. Stands for yet another generation. That's what it expands to. It's an IETF standard. It's so simple, you don't need to be a programmer to be able to write a Yang file. It's just a plain ASCII text file. Any human can read it. And if I show you a Yang file, you'll understand about 50% of it looking at it, and you'll tell me what it is. It's as simple as that. Okay. So the way it works now, the world is going to turn around to us. Everything is going to be controlled by netconf and netconf. Netconf for sure, and Yang is our way of doing it, and most of the industry is leaning towards Yang. Simple. I'll tell you why, because there's already Yang models that is coming out from different standards bodies for OSPF, BGP, and MF. MEF has come up with a Yang model for about 7 services they have. It's already there, MEF standard. So this is where the world is going to. So network engineers can actually do their work of figuring out how to run the network more efficiently rather than sitting and typing the same lines of config over and over again. And everything is done through automation. Okay? I'm not going to go much into netconf and Yang. Here's how NSO is placed. This is typically a company. There's different ways to interact to the network, to NSO. But most of the time, in tier 1s, even though it's a network operating system that gives you a CLI and it also gives you a GUI, most customers actually have their own flow-through systems down in-house, and they talk using REST or netconf to NSO. There's always something on top. And even though we have customers who are using directly CLI, a few of them, but most of the big customers have their own in-house OSS systems that talk to NSO. And the NSO talks to network. Okay? Now it can be physical devices, or it can be the data center, and anything in between. All right. We blow up NSO in the first level. The process, remember I said NSO installs as a process in a Linux workstation. Inside the process, this is NSO in a box. Okay, these are all the elements, hardware, and all the elements over here. This could be a Cisco device, this could be a Alcatel device, this could be a Juniper device, this is an Arista device, doesn't matter. Inside NSO, there's 3 major components. There's a service manager, a device manager, and network element drivers. We call them NEDs. Okay? This is, even though it's shown inside the box, it's actually a pluggable adapter. Okay? The logic of how to talk to each vendor's hardware is inside the NED. So when you install NSO out of the box, there will be no NEDs at all. If you want to talk to a vendor's hardware, you need to drop the NED in. So the NED is, like I said, not for the hardware, it is actually for the operating system that runs on the hardware. So we have a NED for Cisco iOS. There are several hardware that Cisco makes that uses iOS as a platform. So we just need one NED. It will handle every hardware that runs iOS. It will handle every version of the operating system. Okay? It's just one NED.
These are like plugins?
Yes, you drop it in. Like I said, when you install NSO, there'll be no NEDs at all. So it's in when you purchase the product, you purchase the platform, and then you buy the NEDs. So one time.
Licensed out?
Sorry?
Those are all licensed individually, or how?
Correct. Well, the licensing is kind of, I'm not, even though I said I'm a sales guy, I do the technical side of the sales. There is another person who does the business side of sales, so I shouldn't be talking for
So you're an SE?
Yes, correct. I'm a software SE, to be more precise.
So essentially, you buy the NEDs for the vendors that you know that are known on your network, right?
Correct.
Okay.
Correct. All I can tell you is it's a fixed cost for the NED. I don't want to be talking pricing over here, but
So let me me ask you, for boxes like, the 9001 and the 9006 and above, even though they both use XR, they have peculiarities.
Good question, I get this all the time. That single net handles
Take
it.
into account those differences?
Yes, it does.
And so on the 9912, same thing?
Yes. So there are subtle differences in some of the commands, some of them, I don't know why people do that, they'll change the default value from running in one hardware to a different hardware. All the quirks associated with the same operating system running on a different hardware is handled by the net.
How are you dealing with versioning from other vendors? So if I drop in a net for Juniper,
Yeah.
when Juniper comes out with their next iteration, they modify some commands inside of Junos.
Mhm.
How do you deal with that? Is there another net I have to go download and
Okay.
install?
Very good
How does
question.
the process work?
Very, very good question. I get this all, that question also comes all the time. So here's how it works. Juniper is special. Juniper is netconf. Okay? Juniper, it's not a CLI-based net. There's different types of net. Juniper is a netconf-based net. So Juniper is tricky because I'll tell you why. In the latest version of Juniper, Junos, they actually ship the model in YANG file. Let's say it's 14, I don't know what the latest release of Junos is, it's 14.0 or whatever it is.
I have to go back and look.
Yeah, let's say it is 14.0, latest version of Juniper. Come 15.0, they added some extra commands on the device. Question is, do you want to configure the extra commands on your service? Okay, you're creating services using NSO. Okay, if you plan to create a new service and that service requires that 25 extra lines that was added on the new release of the net, then yes, you will have to put a new net in place.
So is that a purchase? Or
No,
is
it's
that
not a purchase.
included? Okay.
It is not a
It's like
purchase.
a one-time fee.
Yes,
Wonder
yes,
if
yes,
Cisco's
exactly.
updating
One-time
that
fee.
revenue.
One-time fee, and I think it's a flat rate fee, doesn't matter for the whole lifetime of the product. So any release comes out, you ask for an update, they'll give you an update for free. Okay? So you have and the beauty of it is, if the device supports netconf and YANG, you don't even have to buy the net. There is a tool that ships with the product, will automatically generate the net for you. But at this very moment, like people are, iOS, they ask, why Cisco doesn't have netconf? Cisco has netconf. Problem is, they started netconf recently in the last 3 years or so, right? iOS XR has been around for a long time. There were so many commands in iOS and iOS XR that it's impossible to create a netconf support configuring all the commands that is available in CLI through netconf over one product release. Because the sheer number of commands that is there in the old operating system. So there's a roadmap for iOS XR, Nexus to add netconf. Actually, the latest versions do have netconf in them, but it doesn't support all the things that you can configure using CLI. It supports part of it. There's a roadmap at some point in the near future, everything that's configurable through CLI will be configurable through netconf. At which point in time, you don't need a net to be purchased. You just purchase a platform and you drop the net on the fly. Make sense? Till such point, if it's a CLI-based, if the device doesn't support netconf fully, then you purchase the net for a flat fee. And all maintenance, everything is included in the fee. If we run into, we have nets for so many vendors. I can show you a list of all the vendors we have. If you have a device, we run into devices, that vendors popping up every other month, every few years. There's new vendors popping up with new hardware. We run into a customer and said, you have a net for Sumito, or you have a net for some big device I've never heard. It's not a problem. We will create a net. Same cost. It takes about 4 to 6 weeks to create a net. And the net the beauty of it is the net can be dropped into NSO at runtime. You don't even have to stop NSO. And you can manage the device on the fly.
So are these nets strictly CLI based?
No,
Or if
no.
you've got a REST API?
Good question.
Or
The net will talk whatever, it can be made to talk whatever the device supports at this point in time. Ideally, it should be netconf. In that case, you generate your own net. You don't have to rely on BU to create a net for it. If the device doesn't support netconf or doesn't support netconf fully, your choice usually is CLI. So we will create a CLI-based net. So basically what will happen is when the service is being provisioned up to here through NSO, it's talking netconf and it converts to the device, it converts it to CLI. Okay? And when you read stuff back, it does the reverse. Sometimes the device has SNMP, you need an SNMP-based net. So literally, we can handle any protocol that the device supports. So whether it be netconf, CLI, SNMP, we also talk to virtual appliances over here. So which means we talk to element managers. Okay, so things like F5 has the element manager called Big IQ. I don't know whether F5 is a firewall. There are firewalls and load balancers out there which are virtual too. And some of the features are not exposed directly on the device. You can't configure on the device. You have to go through the element manager to configure it. In that case, we actually talk usually REST and directly. Most of the element managers, they support REST. We talk REST to the element manager. So downwards, southwards, net can be talking whatever the device requires for configuration management. Make sense? Northbound of NSO, we have two sides. One is the human interaction side, and one is the machine interaction side. Human interaction side you always need because sometimes you will need to go type in some stuff when you are to troubleshoot. By the way, NSO is a single pane of glass. I forgot to tell you. There are customers who have completely cut out access to the devices for network architects and told them go use NSO to talk to the device. So typically, what do they do with troubleshooting? They run commands like show interface status or show OSPF neighbor. Every single command that you can run directly on the device can be run from NSO. Okay? It's a single pane of glass. You can run all show commands, you can configure. You don't need to create a service model to actually configure something. You can, if you're configuring a one-time thingy, you can configure the same thing through NSO as if you're configuring on the device. You can say config SNMP config system service SNMP community string block. You can go, there's no service model needed. You can just go directly configure from NCS CLI and go to the device. Okay? So we have CLI. We have two flavors of the CLI. What I mean by flavors is the style of CLI. So we have Cisco CLI and Juniper CLI. People here will know that if you were to, in Cisco you would go, if you want to remove something, you would say no something. Whereas in Juniper, if you want to remove something, you would say delete something. In Cisco, if you were to create something, you would say L2 VPN block. You just don't say any create before you understand it. Whereas in Juniper, you would say request something. There's a style difference between Juniper and Cisco. We support both styles. So you can interact, if you're a Juniper fan, you can interact in Juniper style. If you're a Cisco fan, you can interact in Cisco style. And the beauty of this thing is you can change it on the fly. You can type switch CLI and flip from one format to a different format. So you can have, if you're a Cisco fan and you're forced to work on a Juniper device, you can actually go to Cisco style CLI and configure the Juniper device, and vice versa. And the good thing is, next time your management decides to buy Alcatel, and you don't want to go learn Alcatel CLI because now you know NSO, you can configure Alcatel using Cisco CLI, Cisco style CLI. I mean, okay. There is also a web interface. So if you're a GUI fan, it's not the prettiest GUI, I have to admit, but it renders everything through a web server running in NSO So you can connect to it through a GUI, and if you want, you can drill down the network and look at different configuration items, or you can create services using our web GUI. It's so the services are auto-rendered on the web GUI. You know, by default, like I say, once you onboard the device, you can click on OSPF, and it will go neighbor. You can click. You can do that. You can walk the tree, but it's not the prettiest GUI, but it works. Like I said, most of the tier ones have their own VSS systems that talk to NSO. Nobody sits and types commands anymore. It's a flow-through processing system that happens, and they talk to NSO using REST, netconf, Java, Python. We even have a customer who is using a C library. They had an OSS system that was written using C, and they wanted to send commands to NSO to create configuration of the device, and we give them a C library. So pretty much everything is exposed up northbound using every protocol possible. But LSConf is missing. There's an LSConf also in play here. Okay, so let me break it up. This is the part that I'm going to lose a lot of people, but I guess I tend to stay away from this one. Out of time. This is a blow up of one more level of, so remember you said there was a nets over here, the service manager takes care of the services, device manager takes care of sucking in the configuration from the device, which sometimes from a CLI net, it comes up as show running config output. We basically do CLI scraping and store the configuration into the database. The device manager handles that. And remember I said you can go, wish I can show hands-on. You don't need to write a service model. If you want to configure something on the device, you can just go to NSO CLI and configure something directly as if you are on the real device. That's managed by the device manager. Okay? The service manager manages, remember the first slide I showed you where there was a map service that you created that goes on multiple devices? That is handled by the service manager. If I went through service manager, device manager, and nets, the rest of the stuff that is there is the database. And so all the configuration is stored in its in-memory database. It's a hierarchical in-memory database. I don't want to go too detail into why hierarchical.
No, I just have a quick question. Is it token-based in terms of the users? So if I have two users on NSO working on the exact same device, is it token-based where they won't override each other? Or how does that work?
Okay, so you can have two users working on the same service. NSO will take care of making sure that it doesn't trample on each other. Okay? So NSO, I will get into the details later. So NSO supports a transaction, an asset transaction. So everything that's written to the device is stored into a transaction. So the next change that is made by the same user, you take time-wise, you can never collide. It's the small time interval between the second user making the change, goes into a different transaction. Okay? So everything is stored in an in-memory database. Why in-memory? Because it has to be fast. Because we are talking about automation, things that should happen in seconds, not minutes, or seconds or less. So when the request comes over here and comes out over here, the time spent inside should be in the order of seconds. That's why everything is on an in-memory database, and there's a reason why it is hierarchical. I don't want to go into the details of it. And it is journaled onto the disk as a backend. Okay? What else? There's a package manager that takes care of swap. I told you can drop nets on the fly without having to start NSO. So you can do a net update without restarting. Just drop the net, and on the package manager, you issue a command called package reload, and it automatically loads the new net. Same thing if you have a new vendor's hardware, you just drop this thing and say package reload, and automatically you have support for the vendor. You have security, it's AAA. We have a whole module that handles security. If I can talk in things about security, about authentication versus authorization and what it means. But there's two aspects of security. High-level username password is authentication. Authorization is what that user who has been authenticated is allowed to do. What can he do? what can he see and what can he do? Sometimes they'll say, well, this user can only see our West Coast network. And inside the West Coast network, he's only allowed to see these things, and he's allowed to write these things. That's authorization. Okay? We handle authentication and authorization inside the product, but very rarely do we have a customer who uses our own authorization, because they always have LDAP or Radius or TACACS or something already in place. So basically, we redirect the whole thing back into the external authentication system. What else do we have? I won't go to the details of this. Basically, this is, if you want to make an EastWest call, that's what we use the developer API for. So let's say if you want to configure a service, and the service requires an IP address and a VLAN ID. You don't want the user, well, where do you get the IP address and the VLAN ID? Typically, they will have it, some network architect has got a spreadsheet somewhere, or that's the crudest form I've seen. A spreadsheet somewhere that says, well, this IP address, this network belongs to this customer, this network belongs to this customer, and he keeps updating his spreadsheet, and every time he creates service, he looks and says, oh, I've used up to .10, so this will be .11, and then you will go to update, put .11, and tag it and say, this is the service name. That's the crudest form of doing it. Same with the VLAN ID. He's got another spreadsheet somewhere that says VLAN ID 100 to 120 is for customer X, 140 to this thing is customer Y. When he types configuration, he goes to the spreadsheet, says, oh, that is 49. Okay? Well, people get better, and then they either purchase in something called an IPAM, or they download one of the free IPAMs that is available in open source. What is an IPAM? It's an IP address allocator, so you basically go define your network versus customer into this IPAM, which is software that runs somewhere else. And then, if you have some kind of automation, what you would do is you would make a call out to that system saying, requesting for an IP address. Okay? And the key would be something like a customer ID. Hey, give me an IP, next available IP address, and the system returns you back an IP address. Same thing with the VLAN ID. You can have, as an example. So let's say you wanted to use, you had your own IPAM system in-house, and then you wanted to make a call out. So when you create a service, you just say customer and a bunch of other information, but you don't, you pick the interface in the customer, but you don't tell it what VLAN ID or the address to use. Two parameters come in, before the service is posted, it makes a call east-west out to, and you have an API here. You have the ability to create, we don't ship these, but you're free to write them. We have a tool that generates you a skeleton, which basically has a hook to implement a get, a create, a set, and a delete request. You don't need to implement all of them. You're just doing a get, is all you're doing. You just implement one stub on the get, and inside that stub, and you can write it either in Java or Python. You just make a call out using whatever API your IPAM supports, REST or Java or whatever it is, implement a stub, and then you can create a service that automatically goes out, makes a call to the IPAM, fetches the IP address of VLAN ID, and uses it down to start the configuration. Make sense? I think I've confused everybody enough. Any questions? The crowd is very quiet. I'm getting a few questions here and there, but
What is the difference between the script API and the developer API?
The script API, good question. Script API gives you an ability to create your own custom script. So if you want to execute a bunch of NCS commands and wrap it up, it's basically a bash shell script. And you wrap all the commands into the script, and then you have your own custom command that you can type in NSO to basically execute it. That's what it does. Yes?
Can you talk a little bit about, and if you have this a little later, I'm sorry, the north and southbound API that NSO has?
That's what I covered before, remember?
Oh.
I'll go back. Southbound is towards the device. Southbound is towards the device. Northbound.
Right, I'm talking about, yeah, more about the northbound than
Northbound, we support every single protocol starting from, so you can interact using The most common ones I've seen the customers use these days, I don't know why, is REST. Everybody likes REST. Maybe because a lot of GUIs people out there, they like REST. REST has its own drawbacks in the sense, REST has got, I don't want to go into digging myself a hole here. REST has got 4 commands. There's a post command which is used to create. There's a put command, the pass command which is used to do an update, and a delete command that's used to delete. Everything happens as one autonomous action, which means you make one request, it goes to the web server, and the web server executes this command. Whereas, remember, NSO has the concept of transactions. There's a big difference here. I should emphasize this.
If not REST, then what?
Sorry?
What's the other alternative?
You can use netconf, or you can use JSON RPC. Okay, let me explain what the difference is.
gRPC. Google RPC.
No, we don't support that. Yeah. Okay. Let me tell you about transactions. What it buys you. iOS and iOS XR has got a big difference between the two operating systems. When you type something on iOS, a device that runs iOS, what happens is whatever you typed in takes effect into running memory immediately. So if you're trying to configure something, and it requires you to type 10 lines of configuration, as soon as you type the first line, the effect of the first line comes into play immediate, as soon as you hit enter. It's on running memory. Whereas in iOS XR, there's a concept of a sandbox and the actual running memory. The sandbox can be called different names. It can be called configuration database versus running database. There's different names, but basically it's a sandbox where you type the commands. Only when you type in all the commands and type commit does the whole configuration gets moved from the config database to the running database, and things get into effect. Okay? In NSO, everything is in the transaction. So remember I told you of the device manager here? Let's say the device manager was talking to an iOS, a box that is running iOS. No transactions in iOS. Everything goes into running memory. But if you use the device manager, remember I told you any command that you can type on the device after logging in CLI, you can type through NCS CLI over here and go through the device manager. Now you get transaction for free, which means if you type something like SAT system SFP secure community string block, SAT DHCP server something, and enter. Nothing is sent on the device. After you type everything in NCS CLI, you will type commit. That's when everything gets sent to the device. So now you have a concept of transaction even on devices that don't support transactions. The transactions is very, very interesting. You need it, especially when you're doing automation. You need the concept of a running memory versus the configuration memory. So when you use netconf to talk to NSO, it exposes you transactions. So you can actually set all the configuration you want. You can do validation on the configuration that you set and make sure everything is fine. So you have a call to validate. And then you have a call to commit, which moves stuff from running memory from candidate memory. Like I said, there are different names they call it. Netconf calls it candidate memory and running memory. Some other people call it the config database versus running database. Basically, candidate and config is the sandbox. And running memory is what is in effect in the device. So that's why I suggested we use netconf instead, because when you use netconf, you have the ability to validate, you have the ability to write it into the candidate database first before you actually wrap it up into the running database.
So by contrast, if you use REST, you lose that transaction?
You lose that transaction.
So the REST call is the transaction.
Correct.
But if you need multiple REST calls to do the full service delivery,
Each one is a time.
each one is separate.
Yes.
Okay.
Each one is separate. So yeah, now they've standardized a protocol called RESTconf. We support RESTconf, which is basically a watered down, it's a hybrid between these two. You would think it is better than both, but it's actually not. It's a watered down version of netconf, but kind of looks like REST. That's RESTconf. We support that also. Answer your question, and so network, API northbound is RESTCON, NetCon, Java, you have Java, Python, C, whatever you want, northbound. For human interaction, wise CLI and GUI. Southbound, any protocol that the device supports.
RESTCOM, what does it do? Like, one extreme is NetCom, the other is REST?
It's somewhere in the middle. It does a watered down version of NetCon, not with all the capabilities of NetCon. That's what it is.
Is there a recommended northbound?
Yes, if you're writing the whole thing from scratch, and you have the ability to choose one over the other, I would go JSON RPC or NetCon. Because JSON RPC also allows you to do all that stuff. Especially if it is a GUI thing, I would definitely suggest JSON RPC.
Okay, and if it's not GUI?
If it is in NetCon. But like I said, most of the time, I've seen integration, 99% of the time, I see REST. 99, I've yet to see anything else. It's always REST. I don't know why. Everybody loves REST.
Now your Java, Python, C, Erlang, APIs, those all support transactions?
Yes.
Okay.
Oh, good that you brought up Erlang. I didn't even bring it up. I'm surprised you
You had it on one of the slides.
I did, okay.
Yeah.
Anyone know what Erlang is? It's a language that was invented by Ericsson a long time back, now open sourced. iOS, I suppose, was probably written in C, but probably the old Ericsson operating system was written using Erlang. The people on the streets, guess what happens? Ericsson is based out of where? Sweden. Exactly. So the people who wrote NSO were ex-Ericsson guys, so they wrote the heart of the product using Erlang. There is 3 VMs running inside NSO. There is an Erlang VM, there is a Java VM, and there's a Python VM.
Yes.
There are 3 VMs running inside NSO.
You could talk a little bit about compliance checking and.
Yes, coming to that in a second. How am I doing time-wise? Now, what, half an hour, 40 minutes? What time do you guys close usually?
About 8:45.
When the
45?
question stop.
Okay, then I'll go quickly over this. All right. So far I was talking about orchestrating on physical vendors' hardware. We also have a big play in NFV space. So basically data center space, so basically spinning up virtual appliances. So in Cisco we have, I don't know whether you've heard about ASR, virtualized CSR, firewalls, load balancers, all these things are in the virtual space now. We have virtual appliances. CSR is on iOS, XR basically running on a Linux platform. So you don't buy hardware anymore. When you buy, there's no box shipped to you, right? There's no firewall box shipped to you. Instead, you have an image that you get from Cisco, or you purchase from Cisco, so got some licenses. And then on the data center, you said, oh, I want to spin up CSR. And then once it comes up, I want to spin up a virtual ASR and then put some configuration on it. Okay? So I don't want any human interaction. I don't want, people can sit there and type stuff and say, okay, this is in OpenStack, they have to glance the image, specify how many CPUs you need to use on this one, how much memory to use, and then instantiate the whole thing. Once it comes up, you have to wait for on the console till the login prompt shows up. Then you log in, and then you type a bunch of commands for day 0, then a bunch of commands for day 1. All that stuff you have to do for the CSR. Then you have to do the same thing for the load balancer, all that stuff. NSO, you can do all these things without human intervention at all. Okay? We need one more piece to do that. Okay? What you're looking at is the HC Nano NFV stack. This is a standard body that defines how things have to become, broken down in the NFV domain. So they call something called NFVO. That's where NSO sits. It's a network function orchestrator. There's something called a VNFM, which is the VNF manager. We have a product called, I'll show you in a second. So what this one does is, it handles the instantiation of the VM. For example, the VM is a virtual ASR or a virtual CSR. Somebody has to manage the life cycle of the VM, starting from glancing it to bringing it up to making sure health-wise it is okay, right? Because these ones, the VM manager's role also extends to health checking, so it can check the load on the device and spin up more devices on the fly, right? So something as simple as, here is a SLA ping test that goes on and checks how the latency is on a ping. And if it is less than so many milliseconds, that means the device, the appliance is getting overloaded. I will automatically spin up a new one. That is the role of VNFM. Then we have VIM. So we have NSO sits on, that's NSO over there. That is ESC, the product that ships with NSO. I think it's bundled, I don't know. You can buy it with ESC or without ESC. ESC not really takes care of CSRs and virtual ASRs. It's also capable of spinning up other vendors' appliances like F5. I don't know what it has been tested, but I was on a demo the other day. They mentioned a few vendors they had tested with. But as long as they support the standard interfaces on the FC manual spec, in theory, ESC can spin up any vendor's virtual appliance. Okay, it's not a Cisco specific. Currently, it has been tested with Cisco and maybe one or two other vendors. I don't remember the names, but like I said, as long as they adhere to the FC manual spec, it can take care of the life cycle of any vendor's appliance. Okay, I'll go fast on this one. FC manual framework, forget that. I will have to go. I mentioned you earlier, the typical workflow for all these playbooks and all that stuff, they are stateless. They have to create workflow definitions. I already covered this. And so you don't have to do anything. Everything is one single transaction. All right. So, yeah, the other typical vendors, you have to create a script for a playbook for create, modify, delete, and redeploy. NSO, everything is automatic. What else do we have? I need time for a demo. Okay, these are a list of some of the vendors' net. It's not an entire list. It's some of the vendors that we have nets for right now. Just because we don't have it, I'll probably run to 25 slides if I were to put all the vendors' names over there. We have function packs built. NSO, like I said, as a platform, you buy the platform, you buy the nets, then you create your own service models. The service models are created using Yang. I mean, you define using Yang. That's all you need to learn. Yang is a very easy thing to learn. However, if you have difficulty creating your own service models, we have people in-house, advanced services, who will create the models for you. And most of the time, what you've seen is the first service model, the customer usually lets the AS do it, and then there's some knowledge transfer, and then they pick up and they start doing their own. Okay.
And the Yang is used to define a device model as well as a service model.
Actually, the Yang is used in the net. It's not the device model. Yes, actually, you're right. The device model is what is there in the net, and that's actually written on Yang also. So, I mean, in fact, you can create your own net. We actually, there's a tool that we ship as a product that you can say create a net package, and if you know Yang, and if you can look at another example, you can create your own net if you want to. And the source code is already there. Even the ones that you purchase, nothing is compiled. Everything is, all the code, all the Yang is already there. You can look at it. In fact, we have several customers who, if they're missing in CLI, sometimes you'll be missing, a new release comes out and a few commands got added and you want to call the BU and ask for support for the product, but it might take a week to a few days. Customers are so used to Yang these days, they go add it on their own. And then they send it back to the BU and say, go ahead, add it to your formal release. So it's simple. Why I brought this one is because there are some services that Cisco noticed that every customer was doing repeatedly. And one of the things that customers were using NSO for was IWAN. I don't know what you guys know about IWAN. So we have a function pack from a different VU inside Cisco, which is an IWAN function pack. So you don't have to create your own service model. Most of the IWAN family seems to look the same in our customers. So here is a function pack you can use. You can buy the IWAN function pack. We have a function pack for vBranch, which is something that, let me say, some vendor, like for example, like say Walmart or I don't know, they open a new store, then usually they have to ship them a bunch of hardware to set up the store. They have to set up firewall, one hardware for firewall, one hardware for a router, all that stuff need to be shipped to the store. Instead, now you can, everything is virtualized. If you can work with virtual firewalls and virtual routers, all you ship them is an empty white box with these things already installed in it. It's just one white box. And then you can manage everything through NSO. There's so another function pack that is available is the vBranch function pack. And more are coming on the way.
So what kind of white box is it ship? UCS?
Yes, it's based on UCS. It runs KVM and it uses libvirt.
Which one?
Libvirt. Libvirt is a virtualization library that it uses. All right, what do we have? We have a product called Bayero. Let's go into details of that. I already covered this. Compliance. Sorry. There we go. The one thing that vendors, most of the vendors, however big they are, seem to have a problem is with compliance. So they usually have something called a gold template. All the customers use golden standard. They'll call it. You'll know it's not that it's made of gold, but that's what they seem to call it. It's a golden spec or a golden template, a golden standard, or something gold. They always have. It says, my service should look like this. But because things were done from the time it got created by people typing it on the keyboard, and they didn't comply with the golden template, or the golden template got revised, and there was a few services that was version 1.0 of the golden template versus version 2.0. At some point, people lose track of which of the services are version 1.0, which are version 2.0, what is the difference, which doesn't comply with neither, is the biggest problem that vendors have. So NSO has built-in functionality called compliance check. So we basically drop in the golden template, which somebody typed in CLI, into a template in NSO and say, go run a compliance check against all the services. So it'll go run a compliance check and produce an output in HTML or text, or it's got a bunch of formats that produce an output, and it'll tell you, on these devices, these look different. You're missing a line here, or this value is different, or you have an extra line there. I'll give you a report that you can use to fix the configuration across the network. Make sense? Sorry, all right, I barely have time for a demo. Is that okay, or do you want to go anyone wants to talk about anything specific for NSO? Otherwise, I can just go into a demo at this point, because that's all the time I have left.
Got a question, Mexico.
All right.
Yeah, I've got a question. So this is a very powerful tool, and it can configure, multiple nodes instantly. Is there any kind of safety built into it? Could you make a catastrophic human error and wipe out, 100 devices in one execute?
Very good question. Remember I said we support transactions? So let's say you blew away the entire configuration on the router. Within the next second, you can restore it back to what it was, because we support, all you need is to restore back the configuration. So with what happens is when NSO does the create, it automatically creates a file to do the opposite. So if you did something as blow away the entire configuration, there's always a rollback file which will create back exactly what you blew away.
Could you do something that could isolate those devices, like the IP connectivity that you're coming in on? Could you
cut your own port?
Change that address?
You can right now. You can shoot your own foot if you want to. Like for example, you are on board using the management IP address.
Mm-hmm.
In theory, you can go and drop your own foot.
But you can restrict the user so that they don't do it, right?
I guess.
You can create a user which can only change management IP, and then other users, even if they want, they cannot change it. You can restrict it.
Yeah, thank you, so, you can do
You
that.
can write some safeties into it.
You can, but it allows you to configure everything on the platform right now. You have to take care of that part. I guess the user is, if there's no other questions, I'll jump into a demo.
I got a question.
Okay?
If a customer wants to write their own, service model, and they don't wanna get AS, what would be your recommendation?
Oh, good question. I skipped through that slide. So what happens is when the customer buys NSO, like I said, Yang is simple to learn, but still somebody has to spend about 3 days to learn it. So we have 3 kinds of training that the BU offers, actually 4. 3 for sure. So they have a basic training, which is a hands-on training, which runs for 2 days, I believe.
3 days, Tuesday to Thursday.
3 days, thank you. So your basic training that runs for 3 days basically teaches you about Yang, teaches you how to create a service model, which uses just Yang and a template. Okay, so the service model is made up of 2 things. There's the Yang file, and the other piece is one file which has the config. Remember we saw the bunch of config converted in XML format. And you don't have to write this XML. NSO will generate the XML for you. Okay, so there's one file that's got an XML, and there is a Yang file. The only thing that you do is you tie these things together by replacing the variables to the Yang attributes that you define. That's how. So there's 2 files. So that's called a simple service model. 60% of the time, most of the models that you have can be written using just a Yang and a template. There are some, so basic training will allow you to write those models, which is the most common one that you encounter. The 3-day course, hands-on, DevNet, you have NSO there, you don't have to come, you just come with a laptop and everything's installed in DevNet. You go through it, you should be, by the time you're done with it, you should be able to create your own service models. Advanced training takes up on the basic training. Now, let's say you want to do stuff, remember I told you, let's say you wanted to make a call out to an external IPAM to get an IP address or a VLAN. That you cannot do just by using, because you need to make a call out externally. You need to write some code to do that piece. That you can write neither Python or Java. So the advanced course trains you how to write a service model which has 3 things. The usual Yang and the template file that you learn in the basic, plus the interceptor in the middle, which is basically a callback. If anyone of you are a programmer, and you know what a callback is. So basically, that function gets called when you try to create the service, and it gets passed in all the attributes that the user typed in. And then you can form what you want inside and use those variables in the template. So that's what that thing does. So the advanced course takes care of creating that. I think it also shows you how to do a NFV space use case, I believe. That's what the advanced training goes. Okay, so that is how you would start off learning doing NSO from scratch. All right. Now let's look at a demo. Here is I'm going to show you a layer 3 VPN configuration demo. Here is a typical network, sample network again. MPLS core, a bunch of P's and a bunch of C's.
Is that bigger?
Yeah, can you zoom it?
Yes. I'm sorry, I don't think I can.
You can go to font size, 200%.
The command plus plus?
Oh, there you go.
There you go.
Thank you. All right, simple demo. You know what a P and a C is, right? Please know your customer, then provide edge. So this is an MPLS core. This belongs to some AT&T or Verizon, and basically these are customer edge device over here. What you're trying to create is, so this PE is Juniper PE. This is an optical PE. This is a Cisco iOS XR based PE, and these CEs are all iOS based CEs. What we're going to create is think of it as a bank, let's say Wells Fargo. Their main server is connected to CE6, the main branch. They want just provisioned two branches, one hanging off here and another hanging off here. And you need to configure at this point, you need to configure this CE, you need to configure the Ps on the way to make sure that the VPN happens, okay? So the service model is already defined. Let me show you. You can configure, like I said, there's two human interactions. One is through CLI and one is through the GUI. GUI is going to be painful, it's slow, so I'm going to use CLI for one and the GUI for the next one, okay? So this is the GUI. All right. This is, by the way, this is a custom built GUI. Don't get me wrong here. The default NSO GUI is a form-based GUI. This GUI was custom. You don't get all this topology drawings on a normal NSO service model. Okay. This picture is this GUI is custom written. Okay. All right. So I'm going. I don't know whether you can see this. I'm not connecting to real. I'm using simulators for this demo. I don't have this many. I don't have real devices to back this up, but this is the same as real devices from a configuration perspective. Oops. So I log into CLI. I'm logging as admin user, as Cisco CLI, and do devices.
Can you make it bigger?
Still bigger?
Yeah.
Yeah.
That's good.
How you get there?
Getting there?
All right, give that a go.
There we go.
Perfect. So let me say, show configuration devices. Show running config device. There's nothing on it. I just want to show you there was nothing on C0, for example. There is nothing. Oh, I didn't do it. Let me do a sync from. Okay, there's nothing much on the configuration. This is just the bootstrap configuration. I do devices sync from. This is where it actually fetches all the configuration from the device into NSO. That was just the bootstrap config that you just saw. Okay. Now, if you look at the configuration, see all the interfaces, everything got sucked into NSO. Okay. Make sense? All right. The service model is already defined. I'm not going to go to the service model. I'm just going to show you how to create this VPN. All right. Let me make this bigger. See this? This is the configuration I'm going to paste. I'll run the next one to the GUI. So basically, I'm saying my VPN has a name. This is a name, and I'm calling whatever name it is. You have to specify a route distinguisher. You have to specify a name for the VPN, what the name is. Pick a device, pick an interface, pick a network, an AS number, and a bandwidth. Okay? So this is the same thing that you pick on. So right now, what we're trying to configure is the main office is hanging off CE6. The two branch offices are hanging off CE1 and CE4. Okay? So remember on the picture, oh, not that picture, the bigger one. So CE1, the CE4 and CE6 is where we are configuring it now. CE6, CE1, and CE4. CE1, CE4, and CE6. The main office is here, and the two offices are over here. Okay? So I'm going to configure this using CLI. I go into config mode, and I'm going to paste all this stuff. So, now, nothing has been written to the device at this point. Nothing has been written, okay? Remember, NSO, everything is getting written into the config database. If you want to see what is getting sent to the device, you have to do commit. But before you do commit, you can do a dry run. And let's do a dry run and see what happens. So it tells you what lines are going to get added to the device. So on CE1, you can see you're going to add a policy map called Volvo, a bunch of shape parameters, you're adding an interface, you're forming a description on the interface, based on the interface, you're setting an encapsulation, and you can see what it does. Again, this is on a device neutral format. Okay, so you can see what it is writing on CE4, CE6, PE0. The CE that the PE that the CE is writing to. It shows all the configurations getting written. The plus sign shows things that are being added. Now, if you want to actually see it on what is actually going to be sent to the device, you would do commit dry run out format native. The first one is an iOS device. See look after this. Look after this. This is the line that you're looking for. This character down. Give the name and the data. You're writing up. If you copy paste this to the device, this is exactly what it gets sent out. So you're creating a policy map, configuring an interface description, bunch of stuff. Next device is CE4, CE6, P0. You see this? That's an iOS XR device. You configured a bunch of stuff on the P0. P2 is a Juniper device. We're actually sending in a netconf message. Okay? Because it supports netconf. And there is PE3. PE3 is an Alcatel device. That is Alcatel CLI. Okay? That's what gets sent to the device. And when you say commit, it actually goes in onto the device. Okay? Now from the GUI in properly, see, it is there now. Volvo is here. Okay? Make sense? All right. Now let's say I wanted to change. I said, oh, the route distinguisher value was wrong. I didn't want it to be, not, what did I type in? 999 over here? Oh, it should have been something else.
854. The correct one is 854.
Oh, is it? Okay. 854 it is. So, make the change, and let's say,
Oh, can you make it bigger?
okay. You can do the same thing from the GUI. It will actually show you, let me show you the dry run by itself, then it will make more sense. See, what happens is you have to change it, the pluses, you have to remove, you see the ones on the left side, you have to remove the address list and replace it with a new value. Now, see this? It did it on this device. This is the PE0. Then made a change. It made it on PE2. It was stacked over here. With that. Okay? Now this is the neutral format. Commit, dry run, out format, natives. So if I do a commit, yes. So it's gone to the device. I can log into the device and show you that it has gone in, but you're taking my word for it.
So as a transaction, let's say that CE1, for whatever reason, didn't accept the command.
Right. Good question.
Does it continue with CE4 and CE6 and PE0 and
No.
PE2, or
No.
does it roll the entire thing?
It rolls the entire. So the default behavior in NSO is, because it's a transaction, it's a network-wide transaction. So either all in or nothing in. So if one of the device fails, if anything the device configured, I don't know, device went offline, somebody pulled a wire, something, device was offline, it didn't go through, everything gets rolled back. That's a default behavior of NSO, even though you can override the default behavior. Because there are some use cases where you're configuring a few commands to a bunch of thousands of Cs. We have customers who configure to like tiny boxes that are setup boxes that they turn up every night, that they ship to you in your home. You connect it, and at 12 o'clock at night they push the configuration. And they expect at least 5% to 10% to be not reachable because the customer forgot to power it on or something happened. So So in that case, you cannot just roll back everything because some customer forgot to turn on the power, you can make other customers wait for a day. So you can change the behavior to say, commit the ones you can and leave the rest as it is. But the default behavior is everything goes in or nothing goes in. All right, so if I want to roll back, it is as simple as this. I just pick up this thing and I say, remember, I changed it to something else. There was 9999. That's all I need. Load. What is the load rollback, cumulative, and commit. I can show you a dry run, but it will be the same as before. You'll be replacing 844 with 999. What was that before? Okay. Correct. Yes. I can delete the whole service if you want. It's as simple as typing. I can show you, if I have time, I can show you a creation of a GUI, or I'll just leave it here. How are you doing time-wise? How many minutes do we have?
We need to wrap it up. It's
Okay. All right.
trying to get everybody out by 9.
All right. So all we need to delete is do a no, and it's still not written to the device. Commit, try run, out format native. Will remove the configuration from every device. It sends the write no command to the CEs. It sends the write no command to the PE, the iOS XR PE. It sends the delete config message to the Juniper device and to the Alcatel device. That's as simple as that. Done. Questions? We don't have time to answer.
I've worked for the Shook on this product for a little bit, and it is pretty impressive. It's hard to get a grasp for all of this, particularly if you're fairly new to things like netconf and Yang data models, okay? Those are key terms that you need to put in your head to remember to go and look up and learn more about. It's the way of the future. So at this point, we're going to wrap things up for the evening with our usual draw.